everybody needs out on their table right now is your science binder. Everything else should be in your cubbies at the end of the tables. Okay? So I need to see everybody ready. You should just have your science binder. That was in your pocket. Okay? When you have your binder, then please just take out your packet that we had from yesterday. If those are falling apart, just let it sit there. I'll get it. Just let it sit inside. Okay, and I'll get it after we're done with class. Okay? So you should have your binder and then your packet from yesterday. It has student journal, elements, and compounds. Okay? It should be in your binder. All right, I need you to turn it to the page. It should be the back of the first page that we were working on. It's titled Elements, Compounds, and Mixtures. Okay. Looks like this at the bottom. Elements, compounds, and mixtures. Okay, I see table 2 has their stuff ready. Table 1's working on it. Table 5 is ready to go. We should be at a level 0. Okay, so we have elements, mixtures, and compounds. Which of those 2 words sound or do you know that are similar between elements, compounds, and mixtures?
Where's my pencil?
Janier? Okay, Janier said compounds and mixtures. Why do we think compounds and mixtures kind of are similar? Amarish? Okay, good. She said they have more than one object combined. Any other explanation of why we think mixtures or compounds would be similar? Can you think of anything? So if we take mixtures and compounds, how would we say elements are different? Vincent?
Compounds have 2 things together, but element.
Okay, very good. An element is just made up of one substance. Okay, what was the word we used yesterday when we talked about the snow outside? Pure, okay? So an element is just one pure substance. Can we break it down any further? Give me an example of an element. Michaeli? Okay, in math we talked about 1/2. We couldn't break it down any further. On our periodic table, give me an example of an element. Tyler? Okay, H. What does the H stand for? Do you remember? Good, hydrogen. Can we make hydrogen anything other than hydrogen? No, okay? That is an element. It is one pure substance, and we can't break it down any further. Tyra? Okay, good. O stands for oxygen. Can we make oxygen anything else than oxygen? Okay, we can't break it down any further than oxygen. We could take oxygen and make it into something else, but we can't break it down any further. Amarish? Okay, the wood. We said wood was an example yesterday of an element. Wood is just made up of wood, okay? We can't make it any different. A compound, what would be an example of a compound? Mason? Okay, 2 elements mixed together. Can you give me an example, Michaeli?
H2O.
Good, H2O. Now we know why H2O is called H2O, because it's combined of what? Hydrogen and oxygen. Good. How many hydrogen? 2. That's why we say H2O. So today we're going to talk about why or how elements, mixtures, and compounds are different and how they are alike. Okay? So on this page, I need somebody to read the first paragraph for me. Vincent.
When you were in elementary school, you learned about mixture. Remember that the properties of the mixture depend on the parts of the mixture. For example, salt water is wet like water and salty like the salt. Salt water keeps the properties
largest
magnet
crossover?
attraction.
25. Okay, all right, so we're gonna talk about how, we said mixtures and compounds were similar, but now we're gonna talk about how they're different between themselves. So this paragraph talked about a mixture. A mixture is when we take two elements and we combine them together, but we still keep the characteristics of the two elements we combine. Okay, so for example, in this paragraph, we're combining salt and water. Can water be by itself? Yeah, okay, we can have a glass of water or a bottle of water, and we take the element of salt. Now, when we combine them together, we get something that's like salt water, okay? If you have a mixture of salt water, can you still see the water? Yes. Can you still taste the salt? Yes. So when we put that together in a mixture, we still have the characteristics of both items we combine. We just now have salty water. How many of you like to make your own chocolate milk at home? Okay? My son loves chocolate milk. If we run out of chocolate milk, we have to have milk and Hershey syrup so he can make his own. Okay? He's not little, he's 17, almost 18 years old. He loves chocolate milk. When we take chocolate milk, what are we combining? Okay? Milk and some sort of chocolate syrup. When we combine them, do we still have milk?
Yes.
Yes. Okay, we still have a glass of milk. We can still see the characteristics of milk. Can we still see the characteristics of the chocolate? Yes, but we've now combined them. If we have more milk than chocolate, okay, good, we'll see more milk. It won't be as brown as it was if we have more chocolate. If we pour a ton of chocolate into our glass, what will we see? Okay, it's gonna be really, really brown, but we're still gonna be able to see the milk, and we're still gonna be able to see the chocolate. So a mixture combines elements together, but it still keeps their own properties. Okay, we can still see water, we can still taste the salt when we make salt water. All right? Okay, our next paragraph, a marriage.
Matter that is a pure substance is very different from mixture. Pure substance are made of only one type of matter and cannot be separated by physical means. Pure substances can be divided into two categories, elements and compounds.
Okay, stop right there. So we're taking pure substances, which is just those substances themselves, okay, they're pure, and we can either make them an element or a compound. Okay, go ahead.
You already know that elements are pure substances that cannot be broken down into similar substances. When elements combine to form new substance called compounds. Compounds have entirely new properties, different from the properties of the elements that it contains. Compounds are pure substance made of two or more kinds of atoms bond together. Compounds can also be broken down into simpler substances.
Okay, good. So let's take a compound we've been talking about, water. Water is made up of what elements?
H2.
Okay.
Hydrogen and oxygen.
Good, H2O or hydrogen and oxygen. Okay, what is hydrogen? What kind of state of matter? What is hydrogen? A what? Solid, liquid, or a gas? A gas, okay? Hydrogen is a gas. What is oxygen? Okay, it's a gas also. So their properties would be properties of gases. But when we combine them, is H2O still a gas? No, we've now created a different element. What have we created when we take hydrogen, oxygen? Good, we've now made a liquid. So are the properties of the hydrogen and the oxygen still the same? No, because we no longer have a mixture. We can't, this is no longer a gas and a gas put together. We've now taken a gas, and the way we've combined it, we now have a liquid. So that's why a compound and a mixture are different. Mixture, you can still see what you combine. If I take a glass of chocolate milk, I know I combined milk and chocolate. But just by looking at water, I can't tell that I've combined a gas and a liquid, ladies. Okay? So that's why this is a compound, because now our new substance that we formed is no longer the same characteristics of a gas. Now, there is hydrogen and oxygen in the water, okay? That's why fish breathe the oxygen out of the water. But when we look at it, can we see the hydrogen and the oxygen when we see water? No, we just know that it's in there. So the characteristics and the properties have changed. That's how a compound and a mixture are different, okay? Everybody on their table has a bag, okay? Open up that bag. You see 4 different colored blocks. Also in that bag, there are 4 different squares of paper that look like this, okay? There are 4 little ones and 4 big ones. Put these 4 little ones aside. You don't need those yet, okay? Take the 4 bigger squares. They have a color and then they have a name of a what on it. Good. Okay, so we have a color and we have an element on our card. So lay out your 4 cards. Put the color square by each of those cards. So blue is going to be what?
Water.
No, what's our card tell us? Oxygen. So put all the blue squares by the blue card. Those are going to be our oxygen atoms. Okay? What is the yellow? Hydrogen. So put all the yellow cubes by the yellow card.
Your homeroom has gotten 2 checks from me,
Okay?
so please make sure they're instituted. And
Absolutely.
Eliza Etheridge and Dennis have actually gotten 3. But every time, it's chaotic.
Okay?
So I'm just letting you know
All right.
in case they forget.
Okay. Yep, thank you. Okay, what is our green card? Copper. So that element is copper. And our red? Carbon. So how many elements are we representing in our blocks? 4. Okay, so we have 4 different elements. What I want you to take first is take the 4 green cubes of carbon. Okay? And just separate them on your table somewhere. Make sure they're not connected. Okay? Anybody have their periodic table handy from yesterday? Yep. Okay? Find this atomic symbol for carbon on your periodic table. Okay? Carbon, yes. Okay? Find the periodic symbol for carbon. Okay? What is it? Okay? All right, good. C6. Okay, but okay, so the red is C6. Find copper on your periodic table. Okay, what is carbon? Okay, Cu and our atomic number? 29. So how many of the carbons do I have up here? 4. Okay? As they are right now, what would this be? An element or a compound? Good, an element. Because why would that be an element? Tyra? Okay, good. They're not joined. What else makes it an element?
That is pure.
Very good. It is pure. It is just copper. Okay? In your packet, flip over to the page. It has 2 long columns. There's an element column and a compound column. Okay? It should look like this.